Hello. Today we are going to look at something called the discriminant in math. And when I first say that, people are usually like, Mrs. Freeze is going to discriminate. So discriminate does not have to have mean, terrible, bad connotations. It can just mean to tell the difference between. So I'm going to give you an example of this. My husband is colorblind, so he can't tell colors apart well. Like, there was one time he had a red golf ball, okay, and he dropped it in the grass, and he got so mad because he couldn't find the thing. He was like, why would they make it blend in with the grass? Who makes golf balls grass colored? And I was like, it's literally right there. But he can't, his eyes don't discriminate between red and green. Red-green color blindness is a thing. So it's not that he's like being mean to green or being mean to red. It's not like that. It's just to tell apart is what discriminate can mean. So that's all we're talking about here. No one's going to be mean to parabolas today, okay? So it's okay. No bullying of parabolas is going to happen. We just want to be able to tell how many solutions we're going to have. So to tell things apart is how we are using this word today. Now, I'm going to use your notes from yesterday. So pull those out because I want to talk about the three different types that we had. So actually, before I do that, I'm going to pull it up on Desmos again. So sometimes when you graph solutions, or graph parabolas and find the solutions, which are also known as the x-intercepts or the roots or the zeros, but we're going to talk about them as x-intercepts. Sometimes there are two x-intercepts. We saw that in our first example. And sometimes there's only one x-intercept. We saw that in our second example. And sometimes there aren't any x-intercepts. Because if you look where this green one hits the x-axis, it ain't going to happen. So those are the different amounts of solutions we can have. And we can find the solutions with the quadratic formula. You can do the whole thing. But sometimes you don't really need to work the whole thing out. You just want to know, like, am I even going to get answers here? Is this even one that has solutions? So that's where the discriminant comes in. Okay, so let me switch over to this now. So I'm going to look at my notes from yesterday. So when we use the quadratic formula on this first problem, we had two solutions. Here they are the decimal forms. Here is the radical form. 3 plus radical 6 and 3 minus radical 6 are the two solutions. We just save ink by writing them together like that. So it has two solutions. The reason it has two solutions is because if you have to add a square root of 6 or subtract a square root of 6, it does different things. So that's why we got two different values here for our x-intercepts. So that hinges on looking at this part that is under the radical, under the square root sign. Okay, so let's look up at the quadratic formula here. You see this part here? The b squared minus 4ac, that's what's under the radical. That's what we are talking about when we talk about the discriminant. Okay, so we look at the part under the radical, the square root sign. So it's the b squared minus 4ac. That's the discriminant. That's how we're going to tell apart how many solutions we have here. So this is the discriminant. Again, no one's going to be mean to any parabolas, okay? We just want to tell if we're going to get one answer or two answers, no answers, what, okay? So there are three possibilities here. So if you look at that b squared minus 4ac part, if the b squared minus 4ac is positive, you'll get two solutions. Oh, sorry, you can't see that, can you? You get two solutions, two x-intercepts, if you want to say, okay? Let's look at the second example that we did yesterday. So here was example 2. We only got one solution here at the end. X was just 1/3. Well, let's think back to why we only got one solution. Look at what's under our square root sign here. So that's the discriminant. The discriminant came out to 0. Well, if you have 6 plus 0 or 6 minus 0, does it even change anything if you add 0 versus subtracting 0? It doesn't change anything. No matter what, that numerator was going to come out to this 6 that we had right here over 18, and then we had reduced it. So if the discriminant, the part under the radical, comes out to 0, you're only going to get one solution. It's not that the solution is 0, but the discriminant is 0, so you only get one answer to the problem. Okay, so let's put that on here. If the b squared minus 4ac is 0, you get one solution. So let me show you that on the graph so you remember it. Let me go back over here. It was the second one that we did here. So if I look, oops, let me zoom in a little bit here. Okay. So my x-intercept happens to be also at the vertex, okay? So that number, that 1/3, 0.3 repeating is 1/3, that is my only solution, my only x-intercept. Only root, only 0, if you wanted to say those things. So, and that comes from the discriminant being equal to 0. Our third example, here was example 3 from yesterday. And we ended up getting imaginary solutions here. We didn't have any real solutions. So let me remind you of the graph of that one real quick. Let me turn that one off. Here was our third graph, and it never hits the x-axis. It doesn't have any x-intercepts, so there are no solutions, no real solutions for this. There are imaginary ones. So let me go back over here. So let's back up from where that I came from. Well, excuse me. Excuse me. So the I, here I see the I, back up a step, here's the I, back up a step, that 8i is coming from the square root of the negative 64. So that negative, if I have to try to square root a negative, so that negative 64 is my discriminant here. If the discriminant is negative, you're going to have an imaginary number, which means there aren't any real solutions. There's only complex solutions. So let's put that on here. If the b squared minus 4ac is negative, you get no real solutions, but there are two, the word for this is complex solutions. So I was calling them imaginary, so, oops, close that, so there we go. If the b squared minus 4ac, the discriminant, comes out negative, then there aren't any real solutions, but you do have two complex ones. So let me look at that. The reason they call them complex is if this part of the fraction is real and that part of the fraction is imaginary. So you're kind of blending what's real and what's imaginary. That's kind of complicated. So the word for that is complex. If there's a part of it's real, part of it's imaginary, so that's complex. So it's okay with me if you just want to say they're imaginary. It's fine. Okay, so what you are going to do today is you are going to have a card sort. So yours will not be on colored paper like this. So I'm really sorry about that. Yours are just boring on white. But so you're going to take these out, and instead of doing the entire quadratic formula, the whole thing, you are just going to focus in on the b squared minus 4ac part, just the discriminant. Work out the discriminant, and then tell me which category if it falls into, whether it falls into the 2 real solutions, real roots, 1 real root, or into there aren't any real roots. Okay, so you're going to sort these into the different categories. So that's everything. So remember, Jesus loves you, and so do I, so do your math.